Good morning, everyone. I welcome you all to this data structure lab session. Till now, we have implemented some of the data structures: stack, queue, circular queue. We have used stack to convert given infix expression to postfix also. Those were the basic data structures, and now today we are going to implement singly linked list. Now, this is your sixth practical from the practical list, where it says that write a menu-driven program. Now, we have been already creating a menu-driven program for all our data structures, right? We have created menu-driven program for stack, queue, circular queue. So similarly, we are going to create a menu-driven program here for singly linked list. So create a menu-driven program to implement following operations on a singly linked list, right? Now here, your practical list says that you need to implement these 6 operations. But what I want is, I want to go through all the operations that we have seen in our lecture session. And I want you to build all those operations here. Not only 6, but we will create insert first, insert last, insert at position, insert before, insert after. So 5 insert. Now we are not going to cover insert sorted here, because if you want to implement insert sorted, then the prerequisite for that is your linked list must be already sorted, and that's not gonna happen here always. That's why we will skip that insert sorted operation in practical program. So 5 insert operations, then delete. So delete first, delete last, delete at position, delete before, delete after, delete first occurrence, and delete all occurrence. 7 delete operations we will go through here. Okay. So total 12 operations I want you all to implement here in the 6th practical. Now, this is gonna be somewhat lengthy program, but it will be, and it need to be. Okay. So here in a 6th practical, we are going to implement singly linked list program with all possible operations that we have seen in the lecture session. That's one thing. Now, second thing, as we are going to create it as a abstract data type. So here in a linked list, we need node. We require a node. So we will create node as a data type, abstract data type, and we'll use that node here. Then third point, till now, I've shown you the entire practical. Stack का पूरा practical करके दिखाया था. Queue, circular queue, conversion, सारे programs मैंने पूरे करके दिखाए थे. So just to make you familiarized with how we are going through this semester, how we are going to create our programs, and now I believe that you are much comfortable with that flow. So now onwards, I'm going to show you limited operations. So let's say I'll show you 3 insert operations, and the rest 2 will be created by you own, right? By you yourself. So just to kickstart your process, I'm going to give you something from my side, and rest of all you are going to complete in your program. But along with that, I'm going to support you in how you can convert your algorithm to program. So from this practical onwards, right, in a singly linked list, I'll show you that if you have a singly linked list algorithm, then from those algorithm steps, how you can write your C code. That's what I'm going to show you, so that you will be able to implement remaining functions also. Okay, so those were a few notes, and let's start our singly linked list program now. So the first thing first, we require the demo part. Demo of single linked list. Now, as you all know, demo structure of a demo program is going to be almost same like others. So let me bring one demo file from the previous programs. So this is the demo file we have created in for Q, right? Now, overall structure is going to be the same for every menu-driven programs. Just the thing is, the header file will change, data type will change, and the menu will change. Definitely, menu is going to be changed. And when we change this menu, we also need to change few cases. But the overall structure will have a while loop infinite. Then we have a switch case. We have a menu, and we call a program functions. That structure will remain as it is. So this was the demo file of Q. Now let's convert this demo file to demo of singly linked list. So for that, we require singly linked list header file, and that we will create very soon. So header file, and this is a demo of singly linked list. Now declare a variable of singly linked list. So here we are going to declare that node, okay, node pointer start. Because when we have a singly linked list, we always have a start node, first node. And the node, this is a new data type. We will create that data type. We'll define that data type in the header file. Then we'll require a few of these variables. We'll see that later. And then init operation is not there. So we do not require this thing. But we do initialize our start with null. Okay. So initialize your start pointer variable to null. And then you go for the number of operations. So let's say this is the operations on linked list or singly linked list, let's say. And then we are going to define all those operations here. So let me define few operations. Insert first. Then my operation list is going to be lengthy, so I'm going to create 2 columns here. Insert last, then new line, and similarly let me define the rest of the operations. So the third one will be insert at position. Then fourth one we say insert before. Fifth one is gonna be insert after. Then I want few delete operations also. So sixth one gonna be delete delete first. Seventh operation delete last. Eighth one delete at position. Ninth delete before. 10th delete after. 11th delete first occurrence. 12th delete all occurrences. And 13th operation will be exit. Well, so we have created our menu here, and we have the numbers 1 to 13. So then we ask user to enter a choice. We have that choice, and we create a switch case here, right? So for 13 number of operations, will require 13 cases here. Definitely, case will differ based on the operation. So I'm going to create those cases here. Exit is 13th case. There is a default case invalid operation. And now here we require case 2, and similarly we require multiple cases here. Right? Now we'll go and define these cases one by one, okay, because we have a lengthy list of operations. So what we'll do here is we'll go and define these cases one by one. So first one, let's say case number 1 is insert first. For that we need to ask user to enter a value. We have that value here, and then we'll call that proper function at this place. Now that's gonna be insert first function, and this function we are going to define in the header file that will create very in a shorter time. It'll require your start node, and we need to pass a value, right? Start and value. Now that will update your start, so need to return it. So start equals to insert first function we are going to call. Now when we insert some values, how do we check whether those values are at proper places or not? So for that we need to display our linked list. Now I'm going to display it by default always. So I haven't created any display menu here. But what I'll do is, before I print this entire menu, I'm going to display my linked list always at this place. So singly linked list contains, and then let us call display operation. Now this operation is also gonna be created in your header file, and it will require your start node, right? So this is what the structure we have created, and we have our entire demo file. Now one by one, when we create operations, we will call those operations from these particular cases. Okay. Right now we have called insert first and display function. So let us go and define these functions in the header file now, so that we can test this this entire implementation using this demo file. So let us create a new file, which is gonna be singly linked list header file for us, and this is going to be the implementation part of your singly linked list. Now how do we implement? Generally the implementation part of our other data structures was looking something like this. Okay. Now this is the implementation of queue using array, not the entire part, initial part. So what we want to do here is we want to go for the implementation of singly linked list here, right? Now we'll require null pointer, so let us include stdlib.h, but we are not going to define the maximum size of our linked list at any point of time. So we don't require this max here. Define queue as an abstract data type. So here we will require node. So define node as an abstract data type. Type def struct node. This is just a label. Now when we define our node, then we define the members of our node data type, or any node. Now if you want to store integer data, you can have integer part here. If you want to store character, float, double, whatever data you want to store, you will require one data part. So we have it here. And the second one, now as long as this is a singly linked list, it is going to have the next pointer, because it is going to point to the next node. So pointer variable next. Now it is going to be it is going to have the address of next node. So data type will be struct node label. So that's the second part of your node, and we define it as a capital node data type. So this capital node we have actually used in our C file when we were declaring start pointer, right? So we have used that node newly created data type here. Going back to implementation file. Now once we define that data type, next thing is operations on queue. So this is operations on linked list. And init operation is not required, but here actually we are going to define all those operations. Insert first we need to define, and we also need to define display operation, right? Because these two operations we have already written in our demo file. So we define these two functions, and then we will test our code. Now if everything is working properly, then we'll go and define the rest of the operations. Fine. So how to implement or how to do this or complete this operation? Now for this, now I'm going to show you how you can take the help of algorithm. So let me bring the algorithm of singly linked list insert first. So this is the algorithm we have seen in our lecture session. Now onwards, you always keep your algorithms with you. Have a look at the algorithm, understand line by line process, and convert that process to the program code now. That will be your next task to complete this entire program. So how do we do that? Insert first is the algorithm process. We require two parameters, start and value. So let us define those two parameters here. We require start, but that is going to be pointer variable because it is address of node. So that's my first parameter, and the second one will be the value. It is a simple integer value, so int 12. We are returning start at the end, right? So it must have a return type node pointer. Okay, so we have defined this function. That line is done. Now in your first step, you check whether avail has some memory or not, otherwise you'll say overflow. But that's not gonna happen here because we have enough memory to store simple integer value, so that's not going to be happening at any point of time. You will never have overflow condition. Now still, if you want to define it, you can. We'll see how, but this step is not needed right now. Next step says you take a memory for new node from avail and update your avail. Now, as I said, all these steps are just for algorithms. In a program, you are going to write malloc statement. Because using malloc, we can allocate a memory runtime in C program, right? So having a new node from avail and updating avail, that will be done by malloc itself. So when we call a malloc function, we will, in return, we will have a new node, n. Now malloc is going to return us the memory, address. So this should be pointer, and it's a node, so node pointer n. Left side and right side of equals to sign must be equal. That's why what we'll do is we will typecast this memory to the node pointer. And malloc requires one parameter, and that will be the size of your memory block. Now, how much size, how many bytes you require, so that is equals to the size of our node. Node को जितनी memory चाहिए उतनी memory allocate करो. So this is the statement you can write whenever you require a new node. Okay, so step number 2 and step number 3 is also done. Now, this statement we need to write every time when we are going to insert a new node. हर बार जब भी आप new node insert करने जाओगे तो आपको ये malloc वाला line लिखना होगा. And just to be at a safer side, because malloc is not going to reset our memory, what we'll do is we will reset that entire memory at our end. We are going to set data null, and we are going to set next pointer null. When we have a new node, we will reset that new node. After that, whatever we want to store, we'll do it. So this is the process you need to do whenever you require a new node. Okay. Now, इसका मतलब तो ये हुआ कि insert first में ये 3 लाइन लिखूंगा, insert last में, insert at position, insert before, insert after. हर बार मुझे ये 3 लाइन copy paste करनी होंगी. Well, if this is the common process we need to go through every time, then what we can do is we can create a separate function for this, create node, and we can have that code here. So whenever we want to run this process, we simply call this function. So that means अगर insert first के अंदर मुझे नया node चाहिए तो मैं क्या करूँगा यहाँ से, I'm going to call that function. I'll simply call that function create node. So create node function will create a new node, and it is going to return me that node address. So the return type will be node pointer. And that node pointer, when it gets returned, I'll have that node pointer in this n. So now onwards, अगर आपको कभी भी insert operation के अंदर नया node चाहिए तो आप ये एक line लिख सकते हो, simple one, and that will create a new node with resetting your memory. Okay, so that's why we have created this function, because we are going to use this function multiple times. Fine, so we have that new node. Next step, step number 4, it says you set your data with the given value. So n points to data is gonna be the given value well. So we are done with step number 4. Then it says step number 5, new node next pointer should be updated with start. So n points to next should be updated with start. So my step number 5 is also done. Step number 6 says you update your start with new node n. So let us update our start with new node n. That is my step number 6. And the last step says you return your start. So return start. And that completes my insert first function. So if you have realized, whatever steps we have written in the algorithm, we are going to follow the same step-by-step process here in the program also. Just you convert your steps to the syntax based on the programming language you are using. That's it. And this is the insert first algorithm. Now, if I want to check whether this is working properly or not, then we need to display our linked list, and the display operation is the traversal process we have seen. Let me quickly go through that thing. So if I want to display my entire linked list, then actually I should print the data part, okay, data part is integer here, and when I'm traversing, I'm going to use tr. So tr points to data, I should print. Now this will have node pointer start as a parameter, and we are going to have one temporary node tr, initialize it with start. So we need to print tr points to data %d, but that's gonna be repeated process. So while now you want to traverse entire linked list, so tr is not equals to null. Till that time, you are going to print your data and you will update your tr with tr points to next. Now this is the process to traverse and print our entire linked list. But before we traverse, we should check emptiness condition. Now, if my linked list is already empty, then I can give a proper message here that linked list is empty. Okay. Otherwise, in the else part, you can have this entire while loop, and here you can complete your else. Now, what should be the emptiness condition? So if your start is already null, then you can say your linked list is empty. Otherwise, it is not empty. It contains something, and we are gonna printing. We will print that data part. Fine. So we are going to print that entire singly linked list data. So one data and then one space. But if I want to print it, just like a linking manner. So after one data, there is arrow, another data, arrow, another data, arrow, and so on. If I want to print that arrow here, then we can print it just like this way. But arrow will be based on one if condition. If there is a next node, अगर next node है तभी हमें arrow print करना है. अगर next node नहीं है, then will not print this arrow. So how do we check next node है या नहीं है? So tr points to next. अगर null नहीं है, that means you have a next node. और अगर next node है तो arrow print करो. Otherwise, don't print that arrow. So this is just the display purpose. आप ये नहीं करते हो, then also it's okay. So that was the display operation, and we have seen the insert first operation. Let us save this entire file now. Now, if we have our set of code lines ready, then we can test it. So let's run this program and let us check it out. So when I run my program for the first time, it says singly linked list contains, and we have a proper message here. Linked list is empty right now. Perfect. And now we have these operations list. Now we have implemented insert first only, so we'll test that part. Let's go for option 1. It'll ask us a value, so let me give it 5. And now singly linked list contains 5. Now there is only one node having 5. Now let us insert few more values here. So option 1, 6. Now 6, I'm inserting 6, but operation is insert first. So 6 जो है वो 5 के आगे आ जाएगा. So now singly linked list contains 6 as a first node. 5 has been pushed to the second position. So after 6 we have one node, तो हमने arrow print करके वो 5 भी print कर दिया. Now this 5 is the last node, so there is no arrow after that. So we have 6 and 5. If we insert one more value, 7, then we'll have 7, 6, 5. we have 7, 6, and 5, right? So that's the simple testing part also. So we have tested our insert first and display operation. Option number 13, to exit. So any query till now? Any question or query till now? Okay. So let's go and implement few more operations, and then you will have your time to complete this program, okay? So let's say next one we want to go for is insert last. Now let me bring the algorithm. This is the insert last algorithm. And we want to implement insert last operation also based on this one. Now this is going to be having two parameters, same as insert first. So node pointer start and integer value. It will return your updated start, so node pointer return type. First line done. Now we already know that for this step 1, 2, 3, and up to step number 3, we just need to write one statement called create node function. So create node function will have a new node from avail, update the avail, and done. Now if you want to check this overflow condition, then you can have if condition on this n, new node. अगर create node को proper memory नहीं मिलेगी तो वो null return करेगा. So अगर आपके new node n में null है, then you can say memory overflow. Otherwise, simply go and continue your process, right? So that if you want, you can have this if part, but let's say right now, up to step number 3, I should only call one line. Node pointer, new node n equals to create node function, and done. Now let's go step by step. Set a new node data to the value. So n points to data equals to given value. Step number 4 is done. Step number 5 says next pointer should be null. So n points to next should be null. So step number 5 is also completed. Step number 6 is if condition. If your start is null, then you simply update your start. So we'll do it here. If my start is already null, then I'm going to update my start with a new node n. Go to step 11 and return your start. So we'll have a return statement at the end. So we'll have this else part, and after this else, we will have return start statement. So step number 6 is also done. Now step number 7 is in the else part. So within else, you have one temporary variable to traverse. Now variable declaration in a C program should be done at the starting of your function. So node pointer tr is a temporary variable we are declaring, and let us initialize it with start. So this step number 7 is written at this place. Then step number 8, it says you go and traverse your linked list up to the last node. Last node पे आप रुक जाओगे. So that while loop we will have in the else portion, where we say tr points to next is not equals to null, then I'm going to traverse. So tr equals to tr points to next. That is my traversal process. So step number 8 and step number 9 we have written here, while loop. Once you complete your while loop, next thing, you update your next pointer of PTR to the new node. So after completing this while loop, TR points to next equals to new node N. That is step number 10. And 11th step, return start, we have already completed. So this is the entire insert last function. We have completed insert last with the help of algorithm. Now let me show you one more operation, insert at position, and that's going to be somewhat complex. So we'll see that also first, and then we will go in our demo file and we will call these two operations. So this is the algorithm of your insert at position, and we want to create insert at position function. Now insert at position. It is also going to return start, and it will have 3 parameters. So it will return start, so return type is node pointer, and there are 3 parameters. First one is your start, so node pointer start. Second and third parameter, second parameter is value, and third parameter is position, right? So we need to pass those things. Now step number 1, 2, and 3, as you all know, creating a new node. So let us create that new node here. Node pointer N equals to create node function. Then step number 4 is set your data. Okay, N points to data equals to value. Then step number 5, it says if your position is 1, okay, then it is kind of insert first operation, where you update your next to start and update your start also, and then you return. So let's have that if condition here. If your given position is 1, user has given POS equals to 1, then what we'll do is we'll set new node next pointer equals to start, and we update our start with new node, and we return start. So we go to step 12 and return start. That's what we have completed here. Now in the else part, you are going to do the remaining process, where you require one traversal variable and counter variable. So let us declare these two variables first. So we require node pointer tr to traverse, and we require one integer counter variable starting from 1. So we have declared these two variables, ptr and cnt. Next thing, we are going to traverse our linked list until we reach at the position -1 place, and at the same time your tr should not be null. So let us write that while loop. While you write your tr condition first, tr should not be null, and at the same time your counter should not equals to given position -1. Well, in that case, we are going to traverse, so tr equals to tr points to next and cnt plus plus. So we have written step number 8, 9, and 10 here. While loop, update your ptr, update your counter. once you complete your while loop, then you need to actually check कि भाई ये दो कंडीशन में से कौन सी कंडीशन फुलफिल ना होने के कारण ये while loop टर्मिनेट हुई। अगर आपको वो पोजीशन मिल गई तो आप नया नोड इंसर्ट करोगे, लेकिन अगर आपका लिंक लिस्ट एंड हो गया बिकॉज ऑफ tr becomes null, तो फिर आपको पोजीशन नहीं मिली, एंड इन दैट केस यू विल से पोजीशन इज नॉट वैलिड. So for that we require if condition here. Right? अगर आपका tr null नहीं है, if tr is not equals to null, then you found a position and you'll insert that new node here. Otherwise, you will give a proper message that invalid position. अगर आपका tr null नहीं है, then you are going to insert a node. When we insert a node, we need to maintain those pointers. So how do we maintain those pointers? नए node के next में tr का next डालो और tr के next में नया node. So let's do that process. New node next will be equals to tr points to next, and then we'll update tr points to next equals to new node n. So we had completed this step number 11 also. Return start is also done. So this is your insert at position operation. Okay. Now here there is one catch here. Algorithm में तो हम वो सारा process नहीं लिखते थे, लेकिन we need to be careful about this thing here. Look, without any validation of position and all, we have created a new node here. So when we start this process, we will create a new node. Now, if your position is not 1, you will go to the else part. And if your position is invalid, then you will go to this else part, declare one message and return. तो ये नए नोड की जो मेमोरी हमने allocate की, उसको तो कहीं पे यूज किया ही नहीं. अगर पोजीशन इनवैलिड थी तो एक्चुअल में हमें वो नया नोड चाहिए ही नहीं. Right? We need not to have that new node. So if you are declaring that memory and data part and all those things before you go for this entire process, then here in this case, invalid position case, you should make your node free again. ठीक है? अगर वो नोड को आप कहीं पे यूज नहीं कर रहे हो तो उसको वापस फ्री कर दो. Otherwise, what you can do is ये दो लाइन जो है create node and set data आपको लिखनी पड़ेगी जहां भी आप नोड यूज कर रहे हो. So if position 1 यहाँ पे भी लिखनी पड़ेगी, and if tr is not null यहाँ पे लिखनी पड़ेगी. So that's your choice. वो दो लाइन को दो जगह पे लिखना है या फिर उसको एक बार लिख के यहाँ पे फ्री करना है. That depends on you, whatever you feel comfortable with. So this is insert at position operation also. So right now we have seen insert last and insert at position code. Let us call these functions from the demo file now. That's gonna be case 2 and case 3. Okay, so we'll call those functions from these cases and we will test it now. So to call those functions, in case 2, insert last. So let me change this function, insert last. When we call that, we pass start variable and we pass a value. We take that value from user. And in return, we will have updated start. Similarly here, in case 3, we call insert at position function, where we are going to pass our start pointer, then one value, and we also require position. So let's take that position from user. So please enter position and we take TOS. Then we ask value, we take that value VAL and we pass all those parameters, and in return we'll have start. So this is the demo code. Let us save and test these two operations also. So I'm going to run this code one more time. Initially my linked list will be empty, so linked list is empty. Let us call insert last value 5. So the first node is the last node, so 5 has been inserted at that place. Let us insert few more nodes at last. So option 2, value 6. So now it will be after 5. So 5, 6 will be your linked list. One more value, 7. So 5, 6, 7. Now alongside these operations, insert first work kar raha hai ya nahi. Let's take it out. So option 1, let me insert 4. So insert first 4 is also working properly. Now let us test insert at position. So option number 3, I'll test position 1 and value is 3, let's say. So yes, it's working properly. 3 is at first place. Now option number 3, let us go for position 4. So 1, 2, 3 and 4. So instead of this 6 option, so position is, let's say, 4, I want to go and insert 0 there. So 6 or 7 जो है वो will be pushed afterwards और उसकी जगह पे 6 आ जाएगा. 6, 7 पीछे चले जाएंगे. So we have that 0 or 6, 7 पीछे चले गए at position 4. That's working properly. And let us also test invalid position. So your choice is 3. Position is something like, let's say, 9 and any value. And then it tells me invalid position and my linked list remains as it is. So all those 3 insert operations are working properly here, and we have tested those operations. Option 13 to exit, and done with the testing part. So that's how you can start your singly linked list program. Now I'm going to stop here. I'll stop this recording also. Now it's your turn to start singly linked list implementation like this way. And our target for today is to complete all insert operations. Okay? You go and complete your 5 insert operations like this way. 3 of those 5 I have already shown you how you can complete. Rest 2, you need to complete it using the algorithm of those 2 functions. Okay? So go and complete your insert operations today. In the next lab, we will see the delete operations. So that's it from my side right now. Let me stop this recording and you start your implementation of this singly linked list program. Do it now. If you feel any difficulty or if you have any error, then you can ask me. We all are here till 11:30. Don't waste your time. Complete this program. Go for it now.